graph each inequality of system inequalities. So we're going to do 9, 17 through 20 on this one. So on this one right here, we need to solve for y. Negative 9 plus 3y greater than 2x. I'm going to move the 9 across. 3y greater than 2x plus 9. Divide by 3. I get y greater than 2 over 3x plus 3. My slope is 2 over 3, and my y-intercept's 3. Now then I'm going to go to 3, draw a dot, and then I'm going to go up 2 over 3. So up 2 over 3, 1, 2, 3, up 2 over 3, and up 2 over 3, and then go backwards, down 2 over 3, down 2 over 3, and down 2 over 3. And then it's a less than symbol, so I'm going to have a dashed line. Put a dash on every tick mark you drew. Put arrows at the end. And then my symbol is greater than. Which way is greater than on y? It's up. So I'm going to shade up like this. So everything above the line would work. Number 4, I need to solve for y, so I'm going to move that 4 across, aren't I? So I'll have negative 2y less than or equal to 5x minus 4. I'm going to divide by negative 2 to isolate the y. When I do this, this flips. So I'm going to have y greater than or equal to negative 5 over 2x plus 2. So I'm going to start at the 2, 1, 2. Then I'm going to go down 5 over 2, down 5, 1, 2, 3, 4, over 2. And I'm going to repeat the process going up. So up 1, 2, 3, 4, 5, over 2. And then I'm going to have a solid line through these dots. I flip my inequality to greater than. That means on the y-axis I'm going to shade up. So the shading will be this way. Any ordered pair over here will work if you plug it in. Any ordered pair over here will not work. This one right here, we got to have 2 equations. This one's already solved for y, but let's solve this one for y. I need to move across my 4x. So I'll get y less than or equal to negative 4x plus 2. I'm going to start at the 2. 1, 2, draw a dot, and then I'm going to go down 4 over 1, aren't I? Down 4 over 1, down 4 over 1, down 4 over 1, and then I'm going to do opposite, up 4, 1, 2, 3, 4 over 1, and up 4 over 1. There's an equal bar, so my line's going to be solid. And I have a less than. Which way is less than on y? Y is less than going down, so my y-axis will be shaded going down. Then I'm going to have y greater than negative 2. That means it's going to go through the y-axis at negative 2 right here. And it's going to be a dashed line going across the y-axis at negative 2. And it's greater than, I'm going to shade up. And it's double shaded in this area right here in it. Those are the solutions to those ordered pairs. Or those are the ordered pairs that are the solution to the equation. Over here I need to solve both of these for y. So I'm going to do this one. I'm going to move the 3x over. I'll have 2y greater than or equal to negative 3x minus 2. Divide by 2. I'll get y greater than or equal to negative 3 over 2x minus 1. So I'm going to go through the y-axis at negative 1. Then I'm going to go down 3 over 2, down 3 over 2, down 3 over 2, and then I'm going to go backwards, up 3 over 2, up 3 over 2, and up 3 and over 2. And I have an equal bar in my inequality. It's a solid line. Okay, and I'm going to shade greater than is shading up. So I'm going to shade this way. Okay, now then I'm going to graph this one. I'm going to move the x across. So I'm going to have 2y greater than or equal to negative x plus 2. So I'll move my x from the left to the middle. Then I'm going to divide by 2. I'm going to end up with y greater than or equal to negative 1 over 2x plus 1. So I'm going to start at 1 on the y-axis. And then I'm going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And down 1 over 2. And then I'm going to go backwards. Okay, and I need a solid line. It's an equal bar in there. And I'm going to shade greater than is to shade up. And I'm going to go this way with it. Just drew this line. I'm going to go this way. I'm shading up the y-axis, aren't I? So this is the double shaded area right in here in it. That single shaded, none of these will work in either of them. These work only in the top one, these work in the bottom one, and these order pairs work in both equations.